Testing. This one. Hello? Hello? Can everybody hear me in sort of the back area? All good? Perfect. So this is vulnerable design. It's going to be a talk about putting backdoors into open source software and kind of the issue with putting open source as like an invaluable sort of a deal. So I am Matthew Bryant. I'm a security consultant for Bishop Fox out in San Francisco. I also really love to hack web stuff. No matter what it is, I do a lot of source code analysis at my job. I find a lot of vulnerabilities. So this talk is going to be about people who may not be putting these vulnerabilities in by incompetence, but actually on purpose, and how often it's fairly hard to tell the difference between a bad programmer and somebody who's maliciously putting code in on purpose to add a backdoor into software. So this is kind of the big thing I'm going to be targeting. It kind of gets brought up every time we have one of these big hacking events, such as shell shock, which is where people will say, given enough eyeballs, all bugs are shallow. It's just kind of a famous quote everybody brings up. You know, if a project is open source, you're going to have enough people looking through it that all these bugs will eventually come to light, and you know, we're safe. And I'm not disagreeing with, you know, open source is definitely better than if you have a compiled binary that you're downloading. I'm definitely not arguing that. I think it's the best that we really have, you know, but I'm also saying that it's not the most effective thing. I think it's pretty easy to get around, and I'm going to show some examples that really show software that's very popular, and yet anybody could look through the source at any time, and yet, you know, vulnerabilities still existed, and some of them were put in there on purpose with the soul, and the programmers who put them there did it in a way that people reading through the source wouldn't be able to identify the vulnerabilities right away. So this is kind of the structure of the talk. In the beginning, we're going to go through some historical examples of backdoors put into software. Then we're going to kind of move on to some modern examples. Some of the stuff that's been found in probably around like this year even. So it'll, you know, not just older backdoors. We're going to go into creating backdoors and introducing vulnerabilities into software. So how to introduce vulnerabilities to open source software that, you know, smart people who are looking through it wouldn't see or would look over because it made preconceptions of what the code is supposed to look like and kind of fooling the eye a little bit. Then towards the end, we're going to actually go through some actual code snippets that are designed to be deceptive. And then, you know, I'm going to say, what's the vulnerability? So you can kind of get the idea of, oh, I don't really see it, or oh, yeah, definitely I see the vulnerability there. So you can kind of get an idea of, you know, if you were auditing an open source project and you see like a vulnerability, would you find it? So, and we're going to do all of this without mentioning any like binaries. So if something's a compiled binary, I don't think like there's not that level of trust there with open source. You know, if you download a binary, you're kind of trusting a lot. There are people out there who could analyze a full binary and say, you know, it's not malicious, but those people are that group is getting smaller and smaller and smaller. It's a very specialized field, and to analyze a huge binary as opposed to a large open source, you know, software project is very different. The work is much harder for a compiled binary as opposed to if you have the full source code available to you. I'm also going to do all of this, and this was actually fairly hard to do. I'm going to do all this without mentioning any of the NSA's backdooring projects. So, and the reason for that is nation states are cheating. I don't have, you know, millions of dollars to bribe RSA to introduce bad algorithms into their crypto suites. You know, I don't have crazy resources to put people on cryptographic boards that will, you know, purposely try to, you know, introduce vulnerabilities, stuff like that. This is for people, anybody could do it without, you know, millions of dollars. That's the idea. So to start us off, I'm going to play a short clip from one of my favorite movies, War Games, which talks about backdoors a little bit.
Jim, how do I get into that system? I want to play those games. You're not supposed to see any of that stuff. That system probably contains new data encryption algorithm. You'll never get in there. Hey, I don't believe that any system is totally secure. I bet you Jim could get in. Yeah, I bet you couldn't. I bet you he could.
Well, you'll never get in through the frontline security, but you might look for a backdoor.
I can't believe it, Jim. That girl's standing over there listening and you're talking about our backdoors?
Mr. Potato Head. Mr. Potato Head, backdoors are not secrets.
Yeah, but Jim, you're giving away all our best tricks.
They're not tricks.
What's a backdoor?
Well, whenever I design a system, I always put in a simple password that only I know about. That way, whenever I want to get back in, I can bypass whatever security they've added on. That's basically what it is.
Yeah?
So before we kind of delve into all these different backdoors that have been found by various people, I want to talk about what makes a backdoor good. How do you know when you've got a backdoor that was really solid? And I think there's quite a few qualities that you have for that sort of a thing. One is it isn't obvious in source code review. This is, obviously if you have a bunch of really smart people looking through your code, you don't want them to find it. This goes the same for automated scanning, and this is a little bit different from the first example because you might have an external web vulnerability scanner checking against your code that you've written. So if it can find it, it's not exactly a very good backdoor, right? So it also should provide you obviously with some sort of advantage once it's exploited, whether that's a small advantage like local privilege escalation or it's a big advantage like remote code execution. And then finally, what would be a really good thing is if somebody found it, you could not be held accountable. So even if you were the one that wrote that code, you could simply say, oh, I'm a bad programmer. And you'll see through all these examples that bad programmers are very, very common. So you could probably get away with doing that. So having a backdoor that has plausible deniability is very useful. So we're going to go through some historical backdoors, stuff that's been introduced into projects already. We're going to go, our first one is going to be a very obvious example. It's not, I don't think it was designed to be hidden, or at least not stay hidden for a long time. It was just designed to own as many boxes as possible. So I don't know if any of you have ever heard of the VSFTP backdoor. It was introduced basically in July 2011. It was discovered that basically the master binary on the site had been backdoored as long with the source code. So the site had gotten hacked, and the hacker realized that in order to infect more machines, he would infect that source code and add a little backdoor into it. And so basically there was a blog post that came out shortly afterwards that was the creator was like, "And what fun an incident. Earlier today I was alerted that a VSFTP downloaded from the master site appeared to contain a backdoor." So he actually provided the source code that was added in here, and so he modified the string contains line function. And you see on lines 12 and 13, does anybody know what this code does here? Can you tell me? Yeah, that's right. Do you know what that string would be? So it'd be a colon and the closing parenthesis. So it wasn't a very it wasn't meant to be very well hidden. Basically, if you send a smiley face to the server, it would back connect to you with a bash shell, and that was basically how the whole thing worked. So it wasn't very stealthy. In fact, if you were to go even deeper into the code, you could see it was just, if you had just grabbed through it, you could have saw that it was in there. But so while this wasn't incredibly clever, it was actually very, very simplistic. It actually got a lot of people, so much so that there's a Metasploit module available. So if you see a server with this version on it, you can actually run it against it and see if during this time, because they obviously didn't catch it right away, a lot of people downloaded it and installed it on their servers. So you can actually use this to hack a lot of servers, and right after this incident, a lot of people did get hacked. So obviously the missing quality there is we're missing quite a few things. One is it's incredibly obvious. Anybody who looked at that source code would be like, well, why are you checking for this very specific string? It's exactly what a backdoor would look like. It's looking for some sort of password to get in, or some kind of. It doesn't fit with the logic of the program. So this next example, and this is one of my favorite stories actually, because it has everything that I would really want to see if somebody was going to backdoor a large open source project. And this was actually an attempt to backdoor the Linux kernel. It wasn't like a remote exploit. It was actually just local privilege escalation. And the way that it was done, I think, was very, very clever. And if we did see a big backdoor put into open source, I think this would be the way to go about it. So in November 2003, an attacker made an attempt to backdoor the Linux source code. It's probably a group by breaking into the Linux bitkeeper repositories. So they actually broke into the servers that they were using to do all the revision control for the source code. So basically, unfortunately, the people who work on this stuff are actually quite smart. So they actually did get caught, which is the only thing that makes this not super cool. So basically, Larry McBoy found that he goes, somebody's modified the CVS tree on kernel.kbits.net directly. They've looked at the machine that currently looks that somebody may have been trying to break in and do it. We fixed the file in question. The conversion is done back here at Bitmover, and we transfer the files. We check them to make sure they're okay. And this file got flagged. So basically, they were looking through all of their commits, and they noticed that some of them, there's some discrepancies in the logs. Some of these commits don't look right. And you'll see here you have like a small comment from DaveM that says, oops, I worked on the wrong file again. He adds 58 lines, deletes 58 lines, adds 2 lines, And then, but you'll notice that he doesn't have a logical change at the bottom of his commits to the project. That's because he had already compromised the server and was forging these commits in directly. So there was no like approval. He just boom, committed straight to it. So, initially they're just like, oh, well, that's, obviously an issue. And then somebody asked, like, out of curiosity, what were those changed lines? Like, what did they modify with these commits? And it's this code right here. Can anybody just by looking at this tell me, and this is like just the lines, if you had this in a huge page, it might be harder, but can anybody tell me what the issue with this code is? What this does? This is the backdoor, this is it. Perfect. Yep. So you'll see current UID equals 0 instead of equals 0. So instead of checking if your current UID is equal to 0, it'll say, oh, we'll make the current user's UID 0. So while this would run as like a higher privilege level, basically it would escalate you to root or whatever, So this is perfect because literally this was the original code. And you'll notice the backdoor is removing one character. So, and that's why they did you see they deleted a big chunk of lines. That was on purpose because if they just deleted the one character, they could see the diff really easily, but they actually modified a bunch of lines, put them all back together to make it a little harder to see what they were doing, but really it was only one character being removed. So now if you hit this, this piece of code while running this program, it would actually escalate your UID to this level. So it's very, very clever. So this failed, unfortunately, because you have like really, really smart people working on the Linux kernel, and they're like, they see any discrepancies at all, and they immediately think it's the NSA. So might not, in smaller projects that aren't as big as this, it might have worked, but they got caught, which is unfortunate, but unfortunate for proving the sort of idea. So a better backdoor is one with plausible deniability. The one before it had a little bit. The one we just talked about had a little bit of plausible deniability, but definitely in this situation it's very obvious that it was malicious. So it's very, very useful because after you write this code and you introduce this backdoor in software, you want people who come to you later and say, like, what is this? Like, were you trying to backdoor the software? And, most situations you can be like, oh, that was a typo. I totally meant to do 2 equal signs instead of 1. Like, anybody could have made that mistake. And it's not like they can hold you accountable for writing bad code. You couldn't be charged in a court of law or anything like that. So you got to think like a bad programmer. These obvious mistakes, and you'll see I've included some code snippets here from screenshots. Bad programmers are everywhere. They probably make up the majority of code, stuff that like your corporations run on, and all the important documents get handled by. It's probably a bunch of Java code written by people who computer science was kind of a good way to get money for them, and they're not really that into it. Does anybody know what the black square, what that code is from? It was in a Black Hat talk rather recently. It's from the TSA baggage scanners. And basically what it does is, it checks your password and authenticates you, and if you have like the wrong password, it fails. But also if it encounters anywhere an exception, if it encounters an error anywhere in doing that, it basically just is like, oh, well, just authenticate him anyways. He's probably cool. So, obviously that's the lowest bidder sort of an issue, but bad programming is everywhere. This next example I really, really like. This is actually something I came upon while analyzing the source code. And this title is correct, by the way. It's a backdoor in a very, very popular backdoor used for like, once you hacked a server, you'd upload this thing. So the C99 shell, I'm curious, has anybody heard of this or used this? You don't have to say if you've used it, but it's kind of like a script kiddie, Swiss Army knife that you would upload after you hacked a server, because it has all these like privilege escalation sort of tools, all written in PHP. So it's very hard to read. So basically, in order to get these shells, people would go to this very popular site, this R57, and they host this shell here. So you basically downloaded it, and you'd upload it to your site you just hacked, whatever it is. And then you would basically have this full panel for executing commands, looking for a way to escalate privileges, brute force services, stuff like that. So the issue is, by default, when you get this shell, there's no password on it, which, people will upload them and they won't ever put a password on it, and then people will come by and be like, oh, free server, and like take over the thing. So in order to set a password, you have like a little configuration part here. So you set your username, password, or you could set an MD5 hash if you don't want to give away your password. And then all you have to do is turn login to true. And upon doing that, basically, now you get like a prompt whenever you visit the shell. And you might want to change the banner too, because you don't want like a server administrator to come by and be like, C99 shell, and then like Google it and realize that they got hacked. So this is basically mostly to protect against other hackers who might be searching for these shells online. In fact, it's fairly popular to just Google C99, especially now after you see the issue with it, to find other people's shells and take over their cool hacks or whatever. So this is quite big, and you don't really need to know all this code. But basically, we have a simple statement that says, you know, if login is enabled, then check their password, and if they have a wrong password, just quit, drop out, you know, exit the program. So what's interesting though is right above this, you know, checking if login is enabled statement, you see this. Is anybody in here like fairly familiar with PHP and would know what the extract command does? What? What it does is actually that's kind of how they used it. So that was kind of their use for it. But basically, if you hand it an array, it'll basically say like, okay, well, we'll set. So you see this array here. We have color equals blue, size is medium, shape is sphere. So we'll set the variable color equal to blue. They'll set size equal to medium and shape equal to sphere. So basically, like unwraps these into actual variables. So can anybody see the issue with that being right above the login code and just taking this input right there? So I could specify input right here, that little request right there. So you see, if I give it a statement like this, right? I had an array with login in it, and I set login equal to 0. So now when this gets passed to this backdoor, right, it gets past the extract statement, and you notice the @ sign in front of it. That's to hide any errors, so that it doesn't show up in the logs when this happens. It's to silence any warnings and stuff like that. So it'll make login equal to 0. So basically, this whole chunk gets cut out whenever you give that to the shell, right? You can put that in a cookie, if you don't want it showing up in logs. It's very beautiful. So all you have to do is just visit the shell with a URL with that in it, and you just bypass all the authentication. It just gives you the shell to run, right? So it's basically you bypass all the authentication. These people who made the shell, or maybe some people that came by later and modified the shell with this backdoor, it gives them like they can just walk by and steal everybody else's hard work. So backdoors and backdoors, right? Like, I don't know why anybody thought that if they just downloaded a backdoor off a site, that it would be safe or something, like these sketchy hacker sites that host all this source code for a million different shells. I really like the C99 example because I remember in these script kiddie forums when everybody would be like, "Is the C99 shell backdoored?" They like ask about it, and everybody would be like, "Of course it's not. We have the source code. Read it." Like it's don't ask me. Like it's in the source code. You can check it. So many people use this code. It doesn't have a backdoor. Don't worry about it, right? So that's not all, by the way. That authentication bypass was not it. There's more. So when you visit this shell with your browser, there's this in it. I actually found this first, which is what led me to find the other backdoor in it. So this is actually just a piece of JavaScript that links to on their site, right? And it does this, which on its own isn't malicious, but it kind of leads to why this vulnerability is there. What this does here is it basically goes to their server and reports where the shell is currently located. So when you load this in your web browser, right, you get the shell, the infected server responds with the shell, the HTML, your browser evaluates that and says, okay, I got to load this script from this site. It does that. And then it immediately calls home to these guys and says, hey, I've got this, that page on this site. Here's the exact URL to go get it, right? So they, of course, say thank you, great. And then they wait a little bit till maybe, the guy's no longer visiting his shell, come in, and then they can take that shell right over. So basically, hacking is too hard. They had everybody else do it for them. And then they just walk by and be like, oh, for sure, right? So the worst part about this is it's been around for a really, really, really long time. And this is source code that you should, this is even developed by Google or a big company where people are like, oh, the source code is totally competent. Great programmers worked on this. This is some shell by an anonymous team in Russia that put together a big PHP conglomerate. And nobody has taken the time to really look through it and say oh, there's a vulnerability. Because a lot of people are like, oh, well, a lot of people have already downloaded this before me. One of them is bound to have been smart and just look through it, right? So went on, in all of that time, every time somebody installed this shit, this is all the versions of it too. Even the previous versions all contain this bug. Every single version, basically was giving these, every install was giving these hackers more and more servers, right? I have no idea what they used it for. In fact, I don't have access to their server logs, so I can't say how many were infected, right? It's hard to collect metrics on this sort of a thing, but just from how popular the shell was, I imagine it's quite a bit. So it's very clever. And interestingly enough, too, if you guys had just seen the first section of that code, just the extract issue, would you have thought it's a backdoor? Now, I know it's run by a hacking group, but it's also written in PHP, so it's very hard to write secure PHP code. So could have just been like lazy programming, right? It's only when you see the secondary part where the thing like calls home and talks to the mothership about like where it's currently at that you start to think that maybe this is like a on purpose sort of a deal. So that's just one of the vulnerabilities. There's definitely more. So this is another one that's going to move even farther away from that. It's going to be like, this one you can't prove it's a backdoor, but it gives me a very backdoorish feeling. So this is WDB Backup. This is a very, very, very popular download. It's got 2 million active installs or downloads on different WordPress systems. So this is actually by default included when it used to be, it no longer is, but like if you had a Yahoo small business site and you open up a WordPress blog, it would be installed by default as a plugin. So a lot of people use this. So at one point I was auditing through it. And I was like, oh, I actually had the plugin installed, which is kind of embarrassing. And I noticed that there's this random folder in my public web directory that's just a bunch of random hexadecimal characters. And I immediately got like really freaked out. I'm like, oh, well, what is this, right? And I kind of traced it back to the source code of this program. And basically it goes to WP content, which is publicly accessible. And then it does backup dash, these hexadecimal digits, right? But, the real issue is, and obviously just 5 hexadecimal digits enough is not actually like very secure. You can brute force that using web requests and stuff like that. But where they derived this random entropy from is this piece of code right here. So for those who don't really know PHP, that's the database password in WordPress, So it's your raw database password, MD5'd, MD5'd again, and then they chop off the last 5 hexadecimal digits of that to gain secure generation of cryptograph. It's very confusing. I have no idea like why. It just doesn't make any sense to me. None of this really is like very logical to me because PHP has a bunch of built-in functions to generate random like numbers and stuff like that. Like very easy to use stuff, and yet they chose to use this, which is really, really confusing. I actually afterwards was like Googling how to generate a random number in PHP to see if there was some kind of guide that suggested using like a MD5 of a database password. I don't really know. It basically isn't. And the worst part, the first bad thing about this is even if it was completely random, even if that was, cryptographically secure, they did all the right things, there are functions in PHP that could generate actual secure randomness sort of a thing. It wouldn't matter because it basically takes about 1,048,000 requests, right? So if you did about 10 guesses a second, that would take, just over a day to guess the database, to guess what that directory was, to get all of your MySQL backups. So it's the perfect backdoor, and I say that because once this is, since this has been discovered and anybody can use it. Actually, if you still download this plugin, it still has this vulnerability because the developer doesn't care. There's actually like a bunch of tickets in like the support forum for this ticket that are like, oh my gosh, please fix this because you're making us all very, very vulnerable. This is perfect because it's the sweet spot. You'll notice if he had used 4 hexadecimal digits, right, it would have taken a fairly easy, doable number of requests. This would have been widely exploitable. People would have gone out the next day and started hacking a bunch of servers. But this is actually going to take you a day. It's going to take a persistent attacker with like one target that they're working on. They have to really want it. It's not like he's put a lot of people in danger, just the people that people really want to hack. So it takes 1 million requests, like I said, but given a very persistent attacker, right, it would definitely happen. And not to mention, since it's the database password that they're using for the entropy, you could just run this code with a bunch of common passwords and immediately figure out what theirs is, right? So you can remotely check their password to their database unauthenticated with some accuracy. And I like that example because I know there's people who are going to be like, oh, well, that's a very PHP programmer thing, where they're like, oh, well, he just thought, well, it's got to be unique for like every site, and I don't want to make it like what if their random number generator is broken or something? Like, I could definitely see people saying, no, this was just an accident, or it was just bad programming, even though it looks very, very Like, why would you do that? So coding a better backdoor, we're gonna actually walk through like a couple of sections of code here. I'm gonna ask people to identify the vulnerability in it. So feel free to speak up if you see something in any of these code examples. This is a good one here. Even if you're taking like Intro to Computer Science, you might be able to see what the issue is. This is PHP, and a lot of examples are in PHP, so I apologize for that. It's just a language I'm very familiar with, and where vulnerabilities really like to crop up. So what is the issue with this here? You've got, obviously they have password in the source code, which is can anybody tell me? So in PHP, if you see right here, you've got a switch statement, you've got cases. If you don't have like a break after every statement, and this is switch statement, right? So if you don't have like case regular authorized equals false and then break, it'll cascade. So it'll go, okay, well, is the value regular? Okay, it is, false, false. By the default, it'll say false. But then after it goes through that default case right there, it'll actually slide down. So it keeps going down through the code. It says, oh, well, how about this? Case secret password, it'll go through authorized equals true. So every time you run this code, it will always evaluate to true, and you will always have code execution with this. However, just looking at it, you're like, oh, I mean, it's not best practice, but there's no real vulnerability in it. Like, it looks very, like, innocent. And this is something, too, if somebody was reviewing source code, they'd be like, you idiot, how could you forget to put the break statements? This is like, computer science, whatever, right? This is something a very, normal programmer would mess up, right? Can anybody tell me what the issue with this code is? Single equal? Does it look familiar to you guys? Because we just went over it at the beginning of the talk. This is the Linux kernel backdoor that we just talked about. It uses the single equals instead of double equals, so it assigns it. So go on. This one isn't actually a vulnerability, but I really like this one because it doesn't do what you think it does. It looks very innocent. And just analyzing this, you'd be like, oh, sure, it looks great, right? The issue is you'll see that like if that first check fails, right? If user ID is not greater than or equal to 0, there's no return statement at the bottom there. You see what I mean? So it'll just always return a truish statement. And this is actually an entry into they have a contest where people write C that looks innocent but does very bad things. This was one guy's entry, and it was very, very clever because just looking at this looks like such a normal code that you never would think, that there's a vulnerability in this. This one is a different play on it. So this one abuses that PHP is a terrible language. Can anybody tell me how I could, bypass this check here and have it send correct? This one's clever because actually the source code looks completely fine, and it's only if you really know what the string compare issue is with that function in PHP that you would get why this is, very dangerous. Does anybody know? So this one right here, if you set the get password field to an array, it'll throw an error into this function, right? And whenever it encounters that error, it'll be like, okay, we'll just return true. They do equal each other. So this one actually gets brought up in a lot of like PHP fights where people are like, PHP is still a pretty good language, and people are like, oh, what does this code do? And like stuff like that. So it's very, very good, using these little intricacies. This one is cheating. I don't think anybody would ever get this even if I gave this slide out afterwards, because it's basically invisible just by analyzing it. Of course, it does like hashing and stuff like that. The trick with this one is actually quite hidden, but actually works. So you'll notice when it compares the hash to the correct hash, the syntax highlighting is broken. Can anybody guess why that might be? It's because while you can't see it with your eye, the A is actually the Cyrillic letter A instead of the normal A. So what we really have is hash, with this special Unicode letter equals correct hash special Unicode letter. Neither of those are ever defined in the program. We define something very similar with the normal A up above, but down there we can't. It's completely different. So they're both undefined. It'll always execute as true. And this is perfect because if you had somebody analyzing the source, even if they knew everything about like PHP and all of its trickery, they wouldn't see this, right? Because it's indistinguishable to the eye. You'd never be able to tell, even though it's open source and readable. So I like this example particularly. This gets brought up in a lot of like code golf competitions where people show off like their skills with like what a language will do. Because did you know you can put like even Unicode characters in the PHP variable and why that's really scary? So this is like the final one, and this one isn't even a vulnerability in like the code, this is actually what do you guys think this prints? And it's you're going to say the opposite of what it kind of looks like, but what does this print out? It prints out hello world. Does anybody know why that might be? And this is actually not a vulnerability in the code. It's an issue with while you're compiling it. The functionality of this code will change. So when you compile this, the compiler will actually look through your code and it will say, oh, I see a printf. I'm going to go back and I'm going to replace it with the appropriate put statement while it's doing this. And you'll notice that since you've defined this, it'll swap them out, right? So actually it'll print hello world because it's replacing that printf statement with the fput statement up there. So this isn't an issue in the source code. It's an issue with abusing the compiler. And if you have like a bunch of people using like, the same compiler, which is pretty common, you could introduce this and people would, just by looking at the source code, looks very innocent. So you'd have to have somebody who's very, very smart, knows their C very, very well and their compiler stuff well. So I feel those examples were fairly convincing. I'd love to hear if you guys have any more examples of like good backdoors that were put into programs. In order to find these type of things, I visited the Underhanded C contest, which is the only super good competition where people get together and they write backdoors for fun. It's like the whole competition is whoever can write the C that looks the most normal, but does something completely opposite or adds some malicious intent to it, right? And you can, win the competition there. Code Golf is a great one. It's not like about backdoors. It's about actually like a bunch of nerds getting together and they have like programming competitions. And they say, well, how can you accomplish X, right? So I learned a lot about every language. I learned a lot about PHP because people will throw code in there and they'll be like, you have no idea what this does, do you? You can be a programmer for like 20 years in PHP and you have no idea what this does because it doesn't make any sense, right? They really expose all this weirdness to you that you could use to evade source code analysis. Our LOL PHP is a great one, which basically is just a big like talk about all the issues with PHP and all the intricacies that with the language and the issues. If you browse our NetSec, whenever people get into any slap fights about like insecure code and like PHP and like really vulnerable conventions, usually people will bring out these code snippets. That's where the string comparison function is, where you could pass it an array and bypass the check. That's where I got it from, was two guys were arguing over whether or not PHP is easy to analyze or review in source code. So it's definitely a good source. I appreciate you all for coming. If you have any examples, I'd love to hear them. Are there any questions as far as the content of this presentation? Cool. Well, I thank you all for coming.